Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful session of fluid mechanics where we will be discussing some important questions from various parts of real flow. Yes, we have already discussed the questions from Bernoulli equation, ideal flow in the previous session, and today we will be discussing some beautiful question from the laminar flow in a pipe, turbulent flow in a pipe, laminar and turbulent flow over a flat plate, as well as the modal analysis. So everything after the Bernoulli equation and its application, we are going to cover those areas through this numerical practice session. So please do join me fast, and those who are already here, please do respond me through the comment section if my audio and visual quality are fine. Yes, please keep your pen, notebook and calculator and try to solve as many questions as possible. And if you face any difficulty in solving any question or in understanding any question or understanding the concept, you are most welcome to write me through the comment section. Okay, so shall we start our session? Please mark your presence by writing in the comment section. For those who are attending my session for the very first time, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi, graduated in 2006. I have also cleared engineering services examination in 2009, worked in Steel Authority of India Limited for a couple of years, and I have also worked in a private consulting firm for more than 2 years. From last 10 plus years, I have been into teaching, guiding the students who are preparing for various competitive examinations. Am I audible and visible to you all? Those who are here, respond me through the comment section. And you can connect with me through the mail ID as well, chandra.shekhar7@byju's.com, or you can join me on the Telegram, that is Mechanical by Chandrasekhar, and the link is also mentioned here at the bottom, as well as you can scan the given QR code to be part of my Telegram channel. All right. So shall we start? Do not forget to attend this workshop on 25th of October taken by Richa ma'am. She will be guiding you to have the right strategy to clear the GATE 2025. If you are aspiring to appear for GATE 2025 examination, this workshop is going to be very beneficial to utilize your time and energy in the most efficient manner. You just have to register yourself for this workshop, and the link to register yourself is already mentioned in the description box of this session. So let us start with question number 1. Everybody, please give it a try. So there will only be 10 questions, but each question is very conceptual. It will help you to improve your understanding, revise your fundamentals, and boost up your confidence. So each question is very important, and once you solve them independently without any support, then you will develop a lot of confidence and clarity in the fluid mechanics, or more specifically real flow. Yes, do let me know the answer. Consider a fully developed laminar flow in a circular pipe. It is internal flow. When do we have the laminar flow in circular pipe? When the Reynolds number is less than 2000. It means the flow is laminar. That is why the Reynolds number is less than 2000. If the diameter of the pipe is halved, it means D2 becomes D1 by 2. Then, and flow rate and length of the pipe remain constant. Flow rate means discharge and L remain constant. the head loss will increase by a factor of, yes, waiting for your answer. Let me see who will be the one giving me the correct answer. So from the question, it is clear that we need to develop a relation between head loss, which is due to friction, and diameter. The objective is to develop a relation between head loss and diameter, keeping the discharge and the length of the pipe constant. Can you do it? Those who are here, find out the answer, develop the relationship. Once your relationship is correct, this is how the questions are framed. Nobody will be going to ask you the formula based question in GATE examination. All the questions will be conceptual, relation based, and which will require an in-depth understanding of the concept. So we can use the Darcy-Weisbach equation. We can use the Darcy-Weisbach equation, because the Darcy-Weisbach equation is the equation which is utilized to develop, or which is utilized to develop the expression for head loss due to friction. So according to Darcy-Weisbach equation, HL is given by FLQ square upon 12.1 d to the power 5. Darcy-Weisbach equation, HL is given by FLQ square upon 12.1 d to the power 5. This equation is used for steady and uniform flow, when there is no acceleration in the flow. Steady and uniform flow. Whether the flow is laminar or turbulent, this equation is valid for both, right? So if we develop the relation, length is constant, 12.1 is a constant parameter, discharge is given constant, Q and L are given constant. So we can say HL is proportional to F upon D to the power 5. And for laminar flow, in the pipe, F is given by 64 by Reynolds number. F is equal to 64 by Reynolds number. What is Reynolds number? 64 mu upon rho into V into D. 64 is constant, viscosity is constant, density of the fluid is constant. So it is inversely proportional to V into D. And if Q is constant, what is Q? Pi by 4 d square into velocity. If Q is constant, then we can say V is inversely proportional to Q is constant. So we can say V is inversely proportional to d square. So we can say F is proportional to 1 by V, that is 1 by d square upon d. So friction factor is directly proportional to diameter. And if the friction factor is directly proportional to diameter, put in this equation. Put in equation number 1. Put the value of friction factor. So the HL will be proportional to D upon D to the power 5. So HL is inversely proportional to D to the power 4. That is the expression. That is one method. This will be the expression. If you will be able to develop the right expression, then you will get the correct answer. Or what you could have used is HL is equal to delta PL by rho G. And for laminar flow, delta PL can be written as 1 upon rho G. It can be written using the Hagen-Poiseuille equation, 32 mu VL by D square, isn't it? That is called as Hagen-Poiseuille equation, which is used only for, which can only be used for laminar flow through pipe, right? So rho is constant, G is constant, mu is constant, L is given constant. So we could have said, then we could have said HL is proportional, 32 is constant, V upon D square, isn't it? And V is equal to 4Q by pi D square. So because Q is constant, so V is inversely proportional to D square. If we put this in here, then we will get HL is inversely proportional to D to the power 4. What will be the answer? What will be the answer? HL is inversely proportional to D to the power 4. So the correct answer will be 16. Option C is the right answer. The right answer for question number 1 is 16, isn't it? Anybody is having any doubt? You just let me know. Either use the Hagen-Poiseuille equation or Darcy-Weisbach equation, that is purely your choice. But if you are using the Darcy-Weisbach equation, then you need to take care of friction factor. For laminar flow, it is 64 by Reynolds number. And if you are using the Hagen-Poiseuille equation, then it will be more simpler, isn't it? It will be more simple to develop. The relation will become same. Next question from the dimensional and model analysis. Please give it a try. Question number 2. Question says, a 1:20 model of a submarine. 1:20 model of a submarine is to be tested in a towing tank containing seawater. If the submarine velocity is 6 meters per second, at what velocity should the model be towed for dynamic similarity? So we need to find out velocity of the model. Velocity of the prototype is given as 6 meters per second and LP by LM is given as 20 by 1, or we can say LM by LP is given as 1 by 20. Model is a small scale replica and prototype is an actual part. We will use the suffix M for model and P for prototype. Now, because it is a submarine, submarine is a completely submerged body. So we have to, so viscous force is important, drag force is important. As viscous force is important in the analysis, we need to use the Reynolds model law. We must use Reynolds model law. And according to Reynolds model law, Reynolds number of model must be equal to Reynolds number of prototype. And what is the value of Reynolds number? That remains constant. So Reynolds number is rho V L by mu is constant, or we can say rho is constant, mu is constant. So we can say V into L, or V is inversely proportional to L. That is the relationship, because density and viscosity will be taken constant. The fluid is same. The fluid is same. Right? So question is Vm by Vp is equal to Lp by Lm. What is Vm? Velocity in the model prototype is 6 into Lp by Lm 20. 120 meter per second will be the answer. B will be the correct answer, isn't it? The answer to this question is B. Now let me see who will get me the correct answer for the next one. Question number 3. Question number 3 on your screen. Yes, can you give it a try? The question is from the drag and lift. This question is from the concept of drag and lift. The question says an oil droplet, density of oil is 800, this is an oil droplet is rising in still water at a constant velocity of 1 mm per millimeter per second. So the velocity, or let me call it as capital U, is equal to 1 mm per second. Its radius is approximately what we need to apply. It is the concept of terminal velocity, isn't it? The concept is the terminal velocity, the maximum constant velocity, or the constant velocity with which a body will be traveling in the fluid is called as terminal velocity. So U is the terminal velocity. What are the various forces acting on this? There is a weight of the oil is acting in downward direction. Then there is an upward force acting, that is buoyant force due to immersed body. The droplet is completely immersed in water. So buoyant force by water will be acting in upward direction, as well as because it is moving in upward direction, then the drag force will be acting in downward direction, which will oppose the motion. So for vertical equilibrium, can we say buoyant force by water must be equal to drag force plus weight of the oil? Sigma F is equal to 0. That is why velocity will be constant. That is how velocity will be constant, and velocity Fd is a function of velocity. So we can say Fd, or we can say Fb minus W, buoyant force by water minus W naught, is equal to drag force. What is buoyant force by water? Density of water into G into volume of the droplet minus density of oil into G into volume of the droplet is equal to drag force. Drag force can be written by using we can write the drag force by using the Stokes law. We can use the Stokes law. So the drag force is 3 pi mu into, or can we write using the Stokes law? The density, viscosity of water is not given. What is the viscosity of water? Viscosity of water, we have to take viscosity of water is 10 to the power minus 3 Pascal second. 10 to the power minus 3 Pascal second. So 3 pi mu of water into U into diameter, isn't it? So we can say rho of water, so rho of water minus rho of oil into G into the volume of the sphere is equal to pi by 6 into D cube is equal to 3 pi mu of water U into D. So from here we can find out. So this 1D will be getting cancelled out, it will become D square. So D square is equal to 18 pi mu of water into U. This pi and pi will also get cancelled out. Pi will also be getting cancelled out. So it will become, the expression will become 18 mu of water into U upon rho of water minus rho of oil into G. Then it will be under root. If we want D, then it will be under root of this. And once we get diameter, we can find out the radius. So 18 mu of water is 10 to the power minus 3. U is 1 mm per second. That is 10 to the power minus 3 meter per second. Density of water minus density of oil. Water is 1000, oil is 100, oil is 800. So 200 into 9.81. Or let me take it as 10. So this 10 to the power minus 3 will get cancel out. So the diameter is equal to 9 into 10 to the power minus 3 under root meter. And what is the radius? Radius is diameter by 2. So it is 1 by 2 So it will be 3 into 10 to the power minus 3 meter. Can you find it out? Point 047. How much is that? Is it 47 micron? There must be a problem with the unit. Yes, what will be the radius? 1 mm per second. So sorry, what mistake I had done is 2 into 10 to the power 3 na. It will not get cancelled out here. It is not going to cancel out here. It is 10 to the power minus 3 into minus 3 into minus 3. 10 to the power minus 9. It will become 10 to the power minus 9. Isn't it? So it will be 10 to the power minus 9. So this is what the answer is. 10 to the power minus 9 and under root of this into 1.5. 4.74 into 10 to the power minus 5 meter, or we can say 4 point or we can say 47.4 into 10 to the power minus 6 meter, and 1 micrometer is equal to 10 to the power minus 6 meter. So we can say 47.4 micrometer. So 47.4 micrometer is the answer. D will be the correct answer. 47.4 micron will be the correct answer. Do you guys understand it? Any doubt? If anybody is having anything to ask, you just let me know. Shall we move to the next question? Question number 4. Give it a try. The length scale of a model is kept as 1:64. What does that mean? LP by LM will be prototype upon model is be 64, or model upon prototype will be 1/64. The prototype fluid is water, that is, and viscous and gravity both are equally dominant in the prototype. When viscosity and gravity both are important, which means Reynolds model law as well as Froude model law, both the model laws will be applied. Reynolds as well as Froude model law both are applied, right? The required kinematic viscosity of the fluid used in the model is, so we need to find out the kinematic viscosity of the fluid used in the model, isn't it? Only the scale ratio is given. So if we talk about the Reynolds model law, can you let me know the answer? Please give it a try, everyone. Use the Reynolds model law as well as the Froude model law. use both the model laws, Reynolds as well as Froude. Are you guys giving it a try? According to Reynolds model law, V into L upon kinematic viscosity will be constant. So we can say kinematic viscosity is directly proportional to V into L. That is one equation. And according to, now we do not have the velocity, we only have the scale ratio, geometric scale ratio. According to Froude model law, if we apply the Froude model law, then what we will get? According to Froude model law, what is Froude number? V upon under root of Lg is equal to constant. So we can say here V is directly proportional to root L. Put in equation number 1. If we put in equation number 1, then we will get kinematic viscosity is proportional to root L into L. And we can say kinematic viscosity is proportional to L to the power 1 plus 1 by 2, that is 3 by 2. If you are able to develop this relationship, now we can find out the kinematic viscosity in the model. So kinematic viscosity in the model upon in equation form upon prototype is equal to Lp by Lm to the power 3 by 2, isn't it? L to the power 3 by 2. It will be Lm by Lp. It will be Lm by Lp. So kinematic viscosity of model is kinematic viscosity of prototype into Lm by Lp to the power 3 by 2. Put the values. Kinematic viscosity in the model is equal to, what is the kinematic viscosity in the prototype? It is not given, and prototype fluid is water. So dynamic viscosity, I told you, dynamic viscosity of water is equal to 10 to the power minus 3. What is kinematic viscosity of water? That is dynamic viscosity per unit density. Density of water is 10 to the power 3. So kinematic viscosity of water is equal to 10 to the power minus 6 meter square per second. These are the important values you should have an idea of. So 10 to the power minus 6 into Lm by Lp. Lm by Lp is 1 by 64 to the power 3 by 2. That will be meter square per second. So 10 to the power minus 6, 1 by 64 under root of 64, 8. So 1 by 8 cube. Isn't it? So what is that? Take 1 divide by 8 and then cube of this. 1.953 into 10 to the power minus 3. 1.953 into 10 to the power minus 3 into 10 to the power minus 6 meter square per second. That will be the answer. And options are in terms of 10 to the power minus 7 or 10 to the power minus 8. The numerical value is something around 1.95. So we can say it can be written as 0.195 into, it will be 10 to the power minus 9, 10 to the power minus 8. So the correct answer is, what will be the answer? B will be the right answer, isn't it? B will be the correct answer for this one. 0.195 into e to the power or 10 to the power exponential minus 0.8. Question number 5 and 6 are common data question. Question number 5 and 6 are common data. Read these questions and try to solve them. Everyone, give them a try. Please solve this. The velocity field for a two-dimensional fluid flow is given by this. This is from the kinematics actually. This question is from the fluid kinematics. Beautiful question it is, that is why I had included it. It is from the kinematics of the fluid flow. The velocity field of a 2D flow is given by, the velocity in x direction is u naught x by L and velocity in y direction is given by minus u naught y by L, where u naught and L are respectively the characteristic velocity and the length. Question number 5 says if L is equal to 0.2 meter and the resultant of total acceleration in x and y direction at x is equal to n and y is equal to L is 10 meter per second square. So the total acceleration is equal to 10 meter per second square. Then what is the value of u naught? Then the question is to find out the value of u naught. You need to find out the value of u naught. So first of all, find out the total acceleration. U is given as u naught x by L and v is given as minus u naught y by L. So ax, acceleration in x direction, is u into del u by del x plus v into del u by del y. Because it is a steady flow, the flow is steady. V is not a function of time, so that is why the flow is steady, so the local acceleration will be 0. That is why the local acceleration will be 0. So u is not a function of y, so this will be 0. So you just have to write u is u naught x by L multiplied by what is del u by del x. Del u by del x is u naught by L. So ax will be equal to u naught square upon L square into x. Similarly, ay, acceleration in y direction. Similarly, acceleration in y direction. Acceleration in y direction, that is u into del v by del x plus v into del v by del y, because v is not a function of x, so this will be 0. So here it will be v is equal to minus u naught y by L into del v by del y is equal to minus u naught by L. So ay will be equal to, it is u naught square upon L square into y. So if we want the values at x is equal to L and y is equal to L, at x is equal to L and y is equal to L, these values, at x is equal to L and y is also equal to L, what is this ay ax? If you put x is equal to L, so it is u naught square by L, isn't it? And what is ay? Ay is also u naught square by L. And what is the total acceleration? That is under root of ax square plus ay square. So it will be under root of u naught square by L whole square plus u naught square by L whole square. So it will be u naught square by L into root 1 plus 1. Isn't it? So the total acceleration which is given as 10, what is the value given? It is given as 10 meter per second square. So it is given as 10 meter per second square is equal to u naught square by L into under root of 2. And for L is equal to 0.2. If L is equal to 0.2 meter, we need to find out u naught. So put the value. So 10 is equal to u naught square into root 2 upon 0.2. So it will become u naught square is equal to 10 into 0.2, that is 2 by root 2, or we can say it is root 2. So u naught is equal to root 2 to the power 1 by 2 meter per second. That will give you the answer. Root 2, then take under root of the answer, 1.1892. So u naught is equal to 1.1892 meter per second. This will be the value of u naught. 1.189. C is the correct answer. C will be the answer for this question number 5. Isn't it? Question number 6 says, the velocity profiles are same. It is the common data question. The above fluid flow can be described as rotational, irrotational, or compressible and incompressible. For incompressible flow, for two-dimensional incompressible flow, if we want to check whether the flow is incompressible or compressible, what we need to have the continuity equation. For two-dimensional incompressible flow, continuity equation will be del u by del x plus del v by del y must be 0. Check LHS and RHS. If we talk about LHS, if LHS is equal to RHS, first of all find out del u by del x. What is del u by del x from here? That is u naught by L. What is del v by del y? That is equal to minus u naught by L, isn't it? So LHS is equal to del u by del x is u naught by L plus del v by del y is minus u naught by L. So it will become 0, that is RHS. It means the flow is incompressible. Then the flow is incompressible. So the A and B will not be correct options. The flow will be incompressible. And how to check whether the flow is rotational or irrotational? We need to check angular velocity. U is equal to u naught x by L and V is equal to minus u naught y by L. These are angular velocity omega about z axis. So omega z is equal to half of then del V by del x minus del u by del y. Find out the value of del V by del x. That is 0. Del V by del x is equal to 0. And del u by del y, that is also equal to 0. Because u is not a function of y, v is not a function of x. So it will be 0. If it is 0, then irrotational flow. The flow will be irrotational. So the flow is incompressible as well as irrotational. The flow will be irrotational as well as incompressible both. D will be the correct answer for this one. So sometimes the question looks little tricky or complicated from the expressions given, but otherwise it is not that tough. Do you guys understand it? Give me yes or no. Those who are here, those who are watching me live, please mark your presence by writing in the comment section. We have solved 6 questions so far. And then next 4 more questions will be there. And I hope you guys are aware and you have started appearing for the mock test. if you are sincerely preparing for your GATE 2024 examination, it is the right time you should start appearing for the mock test. First of all, you should attempt the subject-wise test, revise yourself, revise the fundamentals, revise the concepts, revise the subject, and appear for. Hi Pradeep, welcome. Good evening, how are you? And then appear for the complete mock test. So for your benefit, for your practice, we have come up with the complete series for the mega mock test. Already had been started from 14th of October. This is the entire schedule along with the syllabus, and the difficulty level will be similar to your GATE examination, and you will be having the pattern same as your actual GATE pattern. Good evening, welcome. Hi civil engineer. Good evening, welcome. How are you? Berwaji. So this is for mechanical engineering. Similarly, there is a schedule for civil engineering branch also. All right. Let us move to the next one, question number 7 and 8. Everyone, please give it a try. Read the question carefully. Beautiful question it is. Read it and give it a try. Even if you are not able to solve in the first go, at least try to understand the question. At least try to develop the thought process how the question will be getting solved. All right. The question says, it is linked question. The question says, the boundary layer formation over a flat plate is shown in the figure. It is not below, it is the figure here. This is the figure. There was no need to have the figure actually. The variation of horizontal velocity u, velocity in x direction, with y, u as a function of y at any x along the plate in the boundary layer is approximated by this expression. This is the relation of velocity profile developed in the boundary layer region. This is our boundary layer region, isn't it? This. The whole region is divided into two parts. One is the boundary layer region, and this part is outside the boundary layer region. You must be knowing the concept how the boundary layer gets developed. Because of the presence of solid surface, there is the region in which velocity getting affected. Because of the presence of solid surface, there is a variation in the velocity. In a small region near the surface, that region is known as boundary layer region, which was given by Prandtl. This region was given by L. Prandtl. This concept was given by L. Prandtl. The question says the most acceptable boundary conditions are. Yes, it is simple theoretical question. What are the most acceptable boundary layer? If we draw the velocity profile at any section x, this is the section. If we draw the velocity profile will look like this. The velocity will keep on increasing, and outside the boundary layer region, the velocity is u infinity, free stream velocity. This is how the velocity profile will be developed over the plate. This is u as a function of y, this is y, and this is u as a function of y. And outside the boundary layer region, velocity becomes constant when the velocity remains constant. Now, so what are the condition? Can you tell me at y is equal to 0, the velocity of the fluid is equal to 0? At y is equal to 0, velocity is 0. A, B and D cannot be true. At y is equal to delta x, delta is the thickness of boundary layer, the velocity becomes u infinity. At y is equal to delta, u becomes free stream velocity u infinity. As y is equal to delta, u becomes u infinity. And at y is equal to 0, the third condition is at y is equal to 0, can we say du by dy is maximum? And if du by dy is maximum, d square u by dy square is equal to 0. At y is equal to 0, du by dy is maximum. Du by dy is 0 is incorrect. At y is equal to 0, du by dy is incorrect. And at y is equal to delta, du by dy will be 0. Fourth condition is at y is equal to delta, du by dy is equal to 0 because velocity becomes constant. Yes. Well done, civil engineer Bairwaji. Good, good, good. Are you able to see the video without any buffering, or you are facing the buffering issue? The next part of the question. The next part. The next part says the expression remains same. Now we need to find out the value of P, Q and R by applying those conditions. What are the conditions? One condition was at y is equal to 0, u is equal to 0. At y is equal to 0, put u is equal to 0. Right? And the second condition is at y is equal to delta, u is equal to u infinity. And the third condition is at y is equal to delta, du by dy is equal to 0. Put these conditions. First of all, put at y is equal to 0, u is equal to 0. At y is equal to 0, u is equal to 0. So we can say 0 is equal to P sine 0 plus R. Sine 0 will be 0, so R will be equal to 0. R will be equal to 0. R0, 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 R0. C cannot be true. And then put the second condition. Apply the second condition. The second condition says at y is equal to delta, u is equal to u infinity. So put it here, u infinity is equal to P sine q into delta. This is equation number 1, let us say. And the third is at y is equal to delta, du by dy is equal to 0. So what is du by dy? From here we can say du by dy is equal to P into q cos qy. P into q cos qy. Isn't it? Third condition. Can you solve it? So at y is equal to delta, du by dy is 0. So 0 is equal to P into q into cos of q cos of q into delta. So can we say here cos q into delta is 0. So q into delta is equal to pi by 2. Cos pi by 2 is 0. So from here q will be equal to pi upon 2 delta. Q will be equal to pi upon 2 delta. Q is equal to pi upon 2 delta. Q will not be 0. So D is the correct answer. If you put Q is equal to pi upon 2 delta here, so u infinity will be equal to P into sine q is pi by 2 delta into delta so delta getting cancelled out, so P sine pi by 2, and what is sine pi by 2? That is 1. So P is equal to u infinity. P will be u infinity. So the correct answer to this question is option D. D will be the right answer. D will be the right answer, isn't it? D will be the right answer. Question number 9, second last question for the day. Question number 9 says, consider fully developed flow of water in a pipe of diameter 2 centimeter. The diameter is given as 2 centimeter. Take care of the unit. The average velocity of the flow is 2 meter per second, that is V. Average velocity. The viscosity of water is 10 to the power minus 3 kg per meter second. I have already told you it may not have been given. Sometimes it may not be given in the question. And the density is 1000. We all know. The friction factor can be calculated by F is equal to 64 by Reynolds number when the flow is laminar. When the Reynolds number is less than 2000, and the friction factor will be calculated by this formula 0.316 upon Ra to the power 0.25 for turbulent flow when the Reynolds number is greater than 4000. The pressure drop over a length of 0.5 meter is the pressure drop. So we can say HL is equal to delta PL by rho G is equal to FL V square by 2GD. So from here we will get delta PL. G and G getting cancel out. So delta PL is equal to rho FL V square upon 2D. The only thing is to calculate is friction factor. Everything else is given to us. We need to find out the friction factor, and for calculating the friction factor, we need to check which value of Reynolds number will be applicable. Can you find out the Reynolds number? Reynolds number is equal to rho Vd by mu. That is equal to rho is 10 to the power 3, velocity is 2 meter per second, diameter is 2 centimeter. So that is 0.02 upon viscosity 10 to the power minus 3. So it will be 10 to the power 6 into 2 into 0.02, 0.04. Or we can say, how much is that? 40,000. Is it 4,000 or 40,000? It will be 40,000. Reynolds number is equal to 40,000. Because it is 40,000, so it is greater than 4,000. So the flow is turbulent, and because the flow is turbulent, so we need to find out the friction factor by 0.316 upon Reynolds number to the power 0.25. Friction factor is equal to 0.316 upon Reynolds number to the power 0.25. So 0.316 upon 40,000 to the power 0.25. That will give you the friction factor. It is 0.0223. 0.0223 will be the value. Put in equation number 1. This is equation number 1. Put the value in equation number 1. So delta PL, which is equal to rho FLV square upon 2D, isn't it? Rho FLV square by 2D. So rho is 10 to the power 3. The options are in Pascal only. 10 to the power 3, friction factor 0.0223 into length is the pressure drop over a length of 0.5 meter. This is L, 0.5 into V square, 2 square upon 2D. Diameter is 0.02. Yes. So this 2 is getting cancelled out with this 2. Can you solve it? In 2000 into 0.5 into 2 divide by 0.02. 1117.22. Delta PL will be equal to 1117.23 Pascal. 1117. 1117.23. So the nearest option is option C. Option C will be considered correct. I hope this is clear. Can we proceed further? So one more question is there, but before that, let me tell you, we are going to start one important series for helping you to memorize the formula from your engineering syllabus. For mechanical engineering as well as civil engineering branch, we are coming with a special type of series, special or unit type of series, where we will test your memory and basically we will make you to revise the formula through the questions. So the series will be going to be started from 25th of October, that is day after tomorrow, after Dashera, and this is the schedule for the mechanical branch. So if you have not subscribed our YouTube channel, please subscribe the BYJU'S YouTube channel, and do not forget to like and share this session also, so that you get the important notifications. Fluid mechanics we will be having on 27th at 8 p.m. Strength of materials will be at 8:30 p.m. on 26th. So this is the schedule, and you will definitely develop the confidence, because so many students are having lack of confidence in memorizing the formula. So you will develop the confidence if you join the session, attend this session with your full dedication and your full positivity. Question number 10, that is the last question for the day. Consider a steady, fully developed flow in a horizontal pipe of diameter capital D. Over a section of length L of this pipe, a pressure drop of delta PL is observed. The average wall shear stress over this section is. Whether the flow is laminar or turbulent, it is not given. Whether the flow is laminar or turbulent, it is not mentioned. So there is a formula, if you are aware, from the Newton's equation of motion or momentum equation, Newton's second law. From the Newton's second law, we develop a relation. The relation is tau is equal to minus dp by dx into r by 2. This is valid for laminar as well as turbulent flow in pipe. This is valid for laminar as well as turbulent flow in pipe. But the question is to find out the wall shear stress. So at R is equal to capital R, or that is D by 2. So we can say tau becomes maximum, that is tau naught. That is the wall shear stress. This tau naught is called as wall shear stress, maximum shear stress. Put the value R is equal to D by 2. So we can say tau naught will be equal to minus dp by dx into R is equal to D by 2. So it will be D by 4. And P is a function of X that is linear. Pressure varies linearly in the steady and uniform flow in a pipe. For a steady and uniform flow in a pipe, the variation of pressure is linear. And if the variation of pressure is linear, so minus dp by dx can be written as delta PL by L because of linear nature. So our expression is tau naught is equal to delta P by L into D by 4. This will give you the answer. That is the wall shear stress. Delta P into D upon 4L. Delta P into D upon 4L. A will be the correct answer. This expression, yes Pradeep, well done. A will be the correct answer. This expression is valid for laminar flow as well as turbulent flow in the pipe. So that completes our session. If you want to join our crash course for GATE 2024 revision, we have started a crash course, revision course for the GATE 2024 aspirants, where we are providing you the live classes, recorded classes, study materials, quizzes as well as the mock test. So you can enroll yourself to have the efficient and the best revision along with the question practice to get the best rank, best possible rank in your GATE examination, you can connect with the mentioned number. And if you are targeting GATE 2025 or 2026, so we have started the long-term batches. So you can get the join the long-term batches also if you are preparing for GATE 2025 or 2026. All right. So that is all from my side. I will meet you next on 25th of October at 6 p.m. to discuss how you should revise your thermal engineering. It is for mechanical engineering. The session will be for mechanical engineering at 6 p.m. I will discuss about the ways, the efficient method to have the best possible revision of your entire thermal engineering for GATE 2024. So see you on 25th, day after tomorrow at 6 p.m. Till then, enjoy, take care, have a good day, and happy Dussehra to all of you in advance. All right, so stay safe, stay motivated, and enjoy the festival. You can join me on the Telegram using the scanning the QR code or using the link which is mentioned on the screen. I will share the PDF of this session as well to my Telegram channel. So let me take your leave for the day. Thank you, enjoy, and Jai Hind.